Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about Rolle's theorem.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals a negative x squared plus 2x plus 15 over an x plus 4, and we have to find the values of c that satisfy Rolle's theorem on an interval from negative 3 to 5. Well, does our function satisfy Rolle's theorem? Is it continuous on a to b? And it is. The only issue we would have is when x equals 4, right, or negative 4, dividing by 0 in our denominator, but it's outside our interval. Same thing with differentiable, we're good there. F of a is equal to f of b. Well, I found that for you, and f of negative 3 is equal to 0, and f of 5 is also equal to 0. So you're good there. So we now can apply Rolle's theorem. So we first need to find our derivative. F prime of x is equal to the derivative of the numerator, so that's a negative 2x plus 2, times the denominator, an x plus 4, minus the derivative of the denominator, which is just a 1, times the numerator, a negative x squared plus 2x plus 15. All of that is good all over x plus 4 squared. So from here, we need to simplify this out a little bit. F prime of x is equal to, let's multiply it out, negative 2x times x is negative 2x squared. Negative 2x times 4 is a negative 8x, 2 times x is a 2x, and 2 times a 4 is an 8. So far, so good, right, with my notes? And we're good. The negative times 1 doesn't really matter here with the 1, so negative, we basically change the signs here, going across, distributing throughout. We have positive x squared, a minus 2x, and a minus 15. I got them all there. Denominator stays the same, x plus 4, all squared. Well, let's combine our like terms where we can in the numerator, so f prime of x is equal to, we have negative 2x squared and an x squared is just a negative x squared. We got them. The 2x and negative 2x cancels, and so we're left with just a minus 8x here. Got that. And then 8 minus a 15 comes out to be a negative 7. Cancel that out. All over our denominator, x plus 4 squared. Now from here, I like to pull out a negative in my numerator before I try to factor this. So a negative comes out, and I have an x squared plus an 8x plus a 7 over an x plus 4, all squared. And now the numerator, it's a little easier to see how it factors. We have a negative, it's an x plus 7 times an x plus 1, all over an x plus 4 squared. Alright, so Rolle's theorem here, once we found a derivative, we want to have it equal to 0, and we're going to solve for our x values, which is our c values here. Now, to do that, though, we only really care about the numerator of a rational function. The denominator, if it equals 0, it's undefined there. For the numerator, we can do that. So we take our numerator, negative x plus 7 times an x plus 1, and set it equal to 0. Now the negatives I don't really worry about, because if I divide by negative 1 to both sides, it kind of eliminates because 0 doesn't really do anything. So now we can set each one in parentheses equal to 0. We have an x plus 7 equals 0, and x plus 1 equal to 0. Subtract 7 on both sides, and x equals a negative 7. If I can write negative 7. The same thing with the 1 equals a negative 1. Now with that, negative 7 is not within my original interval. Cancel that out. And so negative 1 is the only value within our interval. And so our c value is equal to negative 1, and that is the only c value that satisfies Rolle's theorem. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.